Good morning and welcome to the third webinar in PennDOT's 2026 Innovation in Motion webinar series. Thank you for joining us today. Today's webinar, Innovative Processes in Materials Testing, will explore how PennDOT's Bureau of Construction and Materials evaluates new materials and technologies to ensure they meet the performance, safety, and quality standards required for use on Pennsylvania's transportation network. My name is Alicia Keller with PennDOT's Bureau of Strategic Business Operations, and I will be serving as your moderator today. Before we begin, I'd like to review a few housekeeping items. All attendees have been muted for the duration of the webinar. If you would like to enable closed captioning, please click on More at the top of your screen, select Language and Speech, and then choose Show Live Captions. We will hold a question and answer session following today's presentation. If questions arise during the webinar, please submit them using the chat feature. One professional development hour will be awarded for attending today's webinar. To receive credit, please complete the survey linked in the chat and provide the requested information. Please note that today's webinar is being recorded. By submitting questions or comments through the chat, you can set to the recording, retention, and use of those comments as part of this session. At this time, I'd like to introduce today's presenters from PennDOT's Bureau of Construction and Materials. We've got Brent Treblepiece, Garth Breidenball, Mike Matthews, Jay Sangos, Brenda Waters, Matt Briggs, Beth Miller, Mike Barrett, and Mike Hofecker. Welcome, everyone, and thanks for being with us today. Let's get started.
Good morning. My name is Brent Treblepiece, and I'm the Director for the Bureau of Construction and Materials. This morning, the Bureau's Division Chiefs, Section Chiefs, and Lab Unit Managers will be giving you an overview of what it is we do here at the lab, providing support to PennDOT's 11 engineering districts that are responsible for administering our $3 billion annual construction program. Our Bureau works out of the Materials Testing Lab, pictured here, which is a 68,000 square foot facility that opened in April 2009. And we have approximately 140 employees working within our Bureau. Now I'm going to give you a brief overview of our organizational structure within the Bureau of Construction and Materials. Our Bureau consists of three divisions: the Construction Quality Assurance Division, the Engineering Automation and Services Division, and the Materials Division. First, the Construction Quality Assurance Division, which consists of 6 teams across the state that are responsible for administering quality assurance and independent assurance programs by annually completing at least 330 independent assurance reviews on construction materials at our approved material suppliers and construction projects, along with another 400 plus quality assurance reviews performed on various construction operations. Next is the Engineering Automation and Services Division, which consists of 5 sections. While this division's accomplishments aren't necessarily quantifiable, this is probably our Bureau's most innovative division. The photogrammetry and survey section provides support and survey gear to the district survey units. The CAD services section provides CAD support to the district design units. The laboratory system section maintains our electronic construction and materials management system, also known as ECAMS, which contains our approved construction materials lists, approved mix designs, material shipments, manages our material test results, and is also used to submit applications for new product approvals. The project delivery system section provides support for our engineering and construction management system, also known as ECMS, with providing business partner access and administering the help desk. They also continue to build out the Project Delivery Collaboration Center, also known as PDCC, which is a shared digital workspace that allows project teams to store files, review plans, complete forms, track schedules, and communicate in one place, not only in design, but through construction as well. The Construction Services section provides support for our mobile construction efforts and maintains PennDOT's Project Collaboration Center, also known as PPCC, which allows for PennDOT and contractor submittals with automated workflows to manage our construction projects. Finally, the Materials Division, which consists of 3 sections and employs over half of the Bureau's employees. The Laboratory Testing section is an AASHTO accredited laboratory, which on average annually receives approximately 11,000 samples, consisting of 24,000 increments, performing more than 35,000 tests, and the testing is completed on 98.5% of the samples within the targeted turnaround time. The Geotechnical section provides support to PennDOT's engineering districts by providing annually an average of 450 remote camera pipe inspections, 100 district assistances with geotechnical issues, and 10 emergency projects typically related to slides or sinkholes. The New Products and Innovation section typically receives approximately 265 new product applications from manufacturers and producers looking to get their products listed on our approved construction materials list. We also have our Facilities section that is responsible for scanning in the 11,000 samples received annually at the dock, ensuring the samples are delivered to the appropriate laboratory testing unit, and managing the numerous building maintenance contracts that we use to maintain our facility. Now I'm going to turn it over to Garth Breidenball, who is a professional engineer and PennDOT's Chief Materials Engineer.
Thanks, Brent. As he mentioned, my name is Garth Breidenball, and I'm the Chief Materials Engineer for the Bureau of Construction and Materials. The Materials Division houses 4 specific areas: pavement materials, the laboratory testing section, and the new products and innovation section, as well as the geotechnical section. My job is to oversee and manage this group of professional and technical staff to ensure that the department receives high quality materials for construction and maintenance. Ensuring quality construction materials often requires working together with various industry partners, material suppliers, as well as the Federal Highway Administration. Our team members and I frequently meet with these various groups through quality improvement committees and other work groups. These groups foster collaboration towards improving our materials and processes. Our primary mission is to support PennDOT's engineering districts in all things related to materials. Our group qualifies pre-approved products. We also make revisions to update material specifications and policies. One very large effort of the Materials Division is to perform testing on a wide variety of highway materials in our laboratory. To tell you more about some of the testing we do here at the lab, I will now turn the presentation over to Mike Matthews, our professional geologist who manages our aggregate, cement, concrete, and soils unit.
Thanks, Garth, for the brief overview of the Materials Division. Hi, my name is Michael Matthews. I'm the unit manager for aggregate, concrete, cement, and soils. I'll spend the next several minutes going over each of my lab areas and giving you a brief overview of what we do.
The first lab area I would like to talk to you about is the aggregate lab. The aggregate lab is managed by Craig Stoughton. The main function of the aggregate lab manager is to maintain PennDOT's Bulletin 14, which is the approved aggregate producer list. Bulletin 14 contains test results for various quality and consensus properties. The majority of the work that is done in the aggregate lab is the testing of requalification samples. These samples are tested to ensure that each approved product from an aggregate source is meeting the department's specification requirements. The samples are also used to produce consensus property data. This data is then used by asphalt producers when they are doing their mix designs. Another important function of the aggregate lab is performing petrographic analysis on aggregates to ensure aggregate produced from a source maintains the skid resistance level it was assigned on initial qualification. Here's a look at some of the quality testing we do on aggregates. Sodium sulfate soundness is used to estimate aggregate durability against weathering by simulating freeze-thaw damage. LA abrasion evaluates how aggregate holds up to abrasion and impact, giving an indication of its durability for use in asphalt and concrete pavements. Deltary shale estimates the aggregate's durability against wetting and drying cycles. Here is some of the consensus property testing we do. Uncompacted voids measures the loose void content of fine aggregate to assess its angularity, sphericity, and surface texture. Higher void content indicates more angular particles, which provides interlocking and stability in asphalt pavement mixtures. Sand equivalency measures the relative proportions of undesirable clay-like fines or dust in fine aggregate that can reduce performance of an asphalt pavement. Coarse aggregate angularity measures the percentage of fractured facies on crushed aggregate. Higher percentages of crushed particles are needed to improve interlocking and reduce deformation in asphalt pavements. Flat and elongate particles determines the percentage of coarse or aggregate particles that have a ratio of length to thickness greater than a specified value. This test ensures pavement durability by limiting weak, brittle particles that break during compaction. The second lab area I would like to talk about is the concrete lab. The concrete lab is managed by Seth Wolfinger. The main function of the concrete lab is to perform testing on cured concrete to ensure it's meeting this design strength and ensuring it has an adequate air void structure. Another essential function of the concrete lab is to perform forensic analysis on distressed pavements and structures and determining the causes of failure. The concrete lab is also responsible for doing concrete mixes and molding concrete prisms for our evaluation of an aggregate's potential to have adverse alkali silica reaction. Here's a look at some of the specific testing that is done in the concrete lab. Concrete compression tests measure the maximum load-bearing capacity of a concrete sample broken in 28 days. The 28-day break determines if the mix design meets strength to ensure structural integrity. Air void testing, done to evaluate the entrained and entrapped air void system in concrete to ensure there is adequate air voids to protect the concrete from freeze-thaw damage. Forensic analysis, usually performed on hardened concrete that is sent in from distressed pavements and structures. The concrete petrographers examine the concrete and determine the cause of failures, such as ASR, sulfate attack, carbonation, and poor mix design or curing processes. The third lab area is the cement lab. The cement lab is managed by Todd Sakala. The main function of the lab is to test plant and field samples of cements and SCMs to ensure the cement and SCM is meeting the physical and chemical requirements of the AASHTO or ASTM specifications that we are testing them to. Another important function of the cement lab is reviewing testing data and performing tests on cement and SCMs for PEQ applications and recommending the listing of these products in Bulletin 15, the qualified products list for construction. Here are some of the most common tests that are done in the cement lab. Compressive strength, evaluated at 1, 3, and 7 days, are done to ensure that the cement is meeting the strength requirements in AASHTO M85 and AASHTO M240. Initial time was set is the period when cement paste starts to lose its plasticity and begins to stiffen, ensuring adequate time of mixing, placing, and compacting concrete before it hardens. Air content. Proper air content increases workability and durability for issues such as freeze-thaw damage. Chemical fingerprint analysis is done to determine concentrations of key oxides, such as calcium oxide, silicon dioxide, aluminum oxide, iron oxide, and total alkalis. The fourth and final lab area is the soils lab. The lab is managed by Todd Sakala. The main function of the soils lab is to provide test data to geotechnical engineers for design and construction purposes. Soil samples are sent in for testing to determine stability, bearing capacity, and safety for foundations, earthworks, and excavations. Another important function of the soils lab is to provide data for forensic investigations of slope failure. Here's some of the most common tests that are done in the soils lab. Soils classification is done to rate soils based on their suitability as subgrade materials for highway construction projects. Direct shear is done to determine the shear strength of soil materials. This data is then used to determine issues dealing with slope stability. Proctor compaction test is used to determine the maximum dry density and optimum moisture content of soils, which are essential for engineering projects like roads and foundations. California bearing ratio is used to evaluate the mechanical strength of subgrade soil and base materials for road and highway construction. I will now turn things over to Jay Sengaz, who manages our asphalt lab unit.
Thanks, Mike, and hi, everybody. As Mike made the introduction, my name is Jay Sangaz, and I am the unit manager of the Asphalt Lab. In our unit, we have two main lab areas. The first one is called Asphalt Testing Lab, where Don Warden is the lab manager and Adam Edwards is the lab supervisor. Our second lab area is called Asphalt Studies Lab, where Brian Held is the lab manager and Rob Bennett is the lab supervisor. In our labs, we perform Pennsylvania test methods, also known as PTMs, along with AASHTO and ASTM test methods. The asphalt testing lab mainly processes these sample classes listed here. Acceptance samples are the majority of these samples tested in our lab. Then it's followed by field verification, quality assurance, independent assurance, and informational samples. Samples come in two forms to the asphalt testing lab. They're either box samples or core samples. Box samples are used in ignition oven, solvent extraction, and GMM verification tests. When we perform ignition oven or solvent extraction tests, we determine the asphalt content of that mixture and then grade the remaining aggregate to determine the amount of material passing the primary control sieve and the number 200 sieve, as these are used in contract payments. GMM testing, also known as AASHTO T209, determines the specific gravity of asphalt mixtures, where we verify the specific gravity value submitted by the contractors. Core samples are used in density testing, which determines the amount of compaction that the contractors achieve. Here, note that cores are also used for testing the longitudinal joint samples. Acceptance samples come from newly constructed roadways, and the test results are used to ensure that the asphalt mixtures meet the specified criteria in Bulletin 27, and the constructed roadway meets the density requirements in PUB 408. Once the test results score a passing grade, the contract payment for that construction item is made. As you see on the slide, these are the pay factors listed for each criterion. Section 413 specifies the super paved mixtures, and Section 419 specifies the stone matrix asphalt, also known as SMA. Density is 50% of the pay factor for both sections, and it is followed by the asphalt content, which is 30% for super paved mixtures and 25% for SMA. Then 10% pay factor is counted for the fine material that passes the number 200 sieve for super paved mixtures. This pay factor is 25% for SMA. Finally, the last 10% pay factor for the super pay mixture is determined by the primary control sieve. In 2025, the Asphalt Testing Lab processed a total of 9,937 samples. As you see on this slide, the majority of these samples were acceptance samples. We tested a total of 4,806 ignition oven and solvent extraction samples, 3,578 density samples, 817 longitudinal joint samples, and 736 GMM samples. Processing such a large volume of samples requires a tremendous amount of effort and teamwork, and our technicians work around the clock to ensure that these samples are processed in a timely manner. Our second lab is the Asphalt Studies Lab. In the Asphalt Studies Lab, we mainly test the liquid asphalt samples that we receive from suppliers that are listed in Bulletin 15, and they are called plant verification samples. Liquid asphalt comes in two forms. One, performance grade binder, which is used in asphalt mixtures and acts as glue to hold the aggregate together. The second form of liquid asphalt is called emulsified asphalt, which contains asphalt, water, and emulsifying agent. There are many different types of emulsified asphalt, and they are mainly used in maintenance applications such as tack coat, slurry seal, microsurfacing, fog seal, chip seal, and so on. We perform plant verification testing to ensure the asphalt material produced meets the specifications. Besides plant verification samples, The Asphalt Studies Lab performs research samples, and they can be categorized as new product evaluation samples, RAP analysis samples, round-robin samples, and forensic analysis samples. Last year, the Asphalt Studies Lab tested a total of 2,248 samples. As you see on this slide, the majority of these samples were emulsified asphalt samples, with 1,863 samples, followed by 252 PG binder samples and 133 research samples. Thank you for giving me the opportunity to introduce the Asphalt Lab unit. Our staff works tirelessly to make sure the highest quality of materials are used on our roadways. Now, I yield the floor to Brenda Waters. Brenda is the Chief of the Chemistry, Physical, and Instrumentation Lab Unit.
Hello, my name is Brenda Waters. I'm the Chief Chemist at the Materials and Testing Lab. I manage chemical testing, physical testing, and instrumentation testing. Coatings Lab receives samples such as waterborne traffic paints, solvent-borne paints, traffic beads, and rock salts. The waterborne paint, solvent-borne paints, and traffic beads come directly from the paint or bead manufacturer or from the PennDOT project where the products are going to be used. The rock salt comes directly from the districts when they receive a delivery. All the material received must be Bulletin 15 approved. The lab conducts various tests on each product, and each product has a lot number assigned from the manufacturer. We compare the results we obtain from the manufacturer's sample with the results obtained from the product received from the district just to make sure that the sample not only meets specification, but that the product is a representative sample. The tests we conduct on waterborne traffic paint and solvent-borne paint products are density, how much of the paint we can pack into a specific volume, viscosity, how will the product flow? Will it flow like honey or water or somewhere in between? We also test for solids, what remains on the surface after the water or solvent evaporates, and opacity, the ability of the paint to cover and conceal what is hidden underneath. For traffic beads, we test for gradation. We don't want the beads to be too large where they're taken up by snow plows, and we don't want the beads to be too small when they're placed on the surface of the paint that they just blow away or even sink to the bottom. We need a mixture of all size beads. We also test for roundness. Each specific sieve must be 70% round, and overall, the beads must be 75% round to perform well. We also test rock salt for gradation for the same reasons. We don't want the rock salt to be too large that when it's placed down, it can crack someone's windshield, or we don't want it to be too small where the salt melts too quickly. The general chemistry lab, we test everything liquid. If it must be dissolved, we will test it. If we must titrate it, we will test it. If we must conduct specific gravity, we will test it. In this lab, we receive from the districts concrete admixtures and air entraining agents for which we test for specific gravity. If there is a discrepancy with the specific gravity results, we obtain a fingerprint of what the product is supposed to look like by using infrared spectroscopy, where we look at the molecular structure of the product. We also act as a support for other lab areas in the building. They bring to the general lab water, soil, concrete, and we test for pH, chloride, and sulfate. Most products we receive in the lab area are assigned a pass or fail. However, water samples receive an other as we have no specification to fail it by. The last lab in the chemistry area is the X-ray lab. We evaluate most sample products that come into this area via X-ray. We test cementitious material and metals. The cementitious material is Portland cement, pozzolan, slag, bauxite, and blended cement blended with fly ash or slag. These samples are mixed with a powdered flux that acts as a diluent and burned over 1,000 degrees Celsius to form a glass disc. The disc is then X-rayed to determine the percentage concentration of oxides within the cement. We look at how much calcium oxide, silica oxide, and other oxides are within the material. We evaluate it to make sure that it meets the specification listed in the report sent to us by the company. We also test metals in the form of rebar, nuts, and bolts to determine what grade of steel they are made of. We do not evaluate these products by using X-ray. We evaluate them by using spark optical emissions, which identifies all the chemical elements within the metal within seconds. It is much faster, much more precise, and much more accurate than evaluated on the X-ray machine. The physical lab receives products from the districts for field verifications from samples that arrive on projects. These are products that are already listed in Bulletin 15. The technicians evaluate the products according to Publication 408 to make sure they comply with PennDOT specifications. Sample products evaluated in the physical lab comprise of rebar and rebar slice, geotextiles and geogrids, and thermoplastic pipe. All the rebar and rebar splice must be a certain strength depending on the grade of metal. They are evaluated for tensile strength and elongation. How many pounds per square inch does it take to pull the rebar until it snaps? How ductile is the rebar, meaning how long does it stretch before it is unable to return to normal? They test for areas of the rebar that do not contain epoxy coating, where chloride from the concrete can invade the rebar, and they test for epoxy coating thickness. Geotextiles are tested based on the class. Geogrids are tested based on the polymer and its use, and thermoplastic pipe evaluated based on its cell class and polymer it is made from, anywhere from size 15 inches in diameter to 60 inches in diameter.
The last lab I want to talk to you about is the instrumentation lab. The instrumentation lab evaluates samples pertaining to traffic control, such as delineators and traffic sign sheeting. We measure dimensions. We make sure posts fit the mount properly. We make sure the delineators do not crack when subjected to extreme heat or cold temperatures. We also make sure the sheeting is reflective and that there is good adhesion. This lab also maintains the nuclear gauge program. We have 4 districts that use nuclear gauges to measure moisture and density on soil and bituminous. The regulations from the Department of Environmental Protection and the Nuclear Regulatory Commission are always changing, so training is conducted every year on nuclear gauge safety and hazardous materials transport. This section is also responsible for the installation and evaluation of an AASHTO test deck. This requires manufacturers from all over the nation to come to Pennsylvania to install their product on a concrete or asphalt deck for PennDOT employees to evaluate the products over a 3-year period. The product is evaluated for durability, retroreflectivity, and daytime and nighttime color. Thank you for joining the webinar. Again, my name is Brenda Waters, and I'm the Chief Chemist here at the Materials and Testing Lab.
Thank you, Brenda. Hello, my name is Matt Briggs. I'm the Chief of the New Products and Innovation section of our Materials Division. NPI reviews and evaluates new construction products and materials that are submitted by manufacturers for addition to PennDOT's qualified products list for highway projects. Our section has 2 units, engineering support and engineering research. The engineering support unit has a supervisor, a bulletins manager, and 5 engineers. The research unit has a supervisor and 3 engineers of its own. Additionally, our section administrative assistant is the Materials and Testing Lab's receptionist, who handles the lab's conference room and auditorium reservations. Our 2 large auditorium rooms hold numerous meetings and trainings throughout the year. Annually, NPI receives approximately 300 new product applications to review and evaluate. Our primary responsibilities include evaluating the product evaluation applications and tracking them to close out. While doing so, NPI ensures that the material sources have been carefully evaluated as part of the qualification process. The application is reviewed to ensure they meet the appropriate material specifications and testing parameters. Other required parts of the application include independent third-party test data, detailed quality control plans, and confirmation with PennDOT's own lab testing that the products meet the manufacturer's claims. Additional support comes in the manner of ECAMS updates, the tracking of project materials deviations, and the monitoring of Bulletin 15 failures. Our external support includes participating in materials-related committees and task forces. The engineering research responsibilities are to evaluate products and materials that do not have a current specification and comprehensively evaluate them. The goals are to research and provide guidance through material specifications, technical overviews, and user guidelines for products that are desired by design, construction, and maintenance personnel. To support the research before it is even started, interest surveys are routinely used to determine the need. The ongoing product support includes providing historical information on products and materials that they have researched. Our qualified products list for construction is Publication 35, more often referred to as Bulletin 15. This is a listing of the most commonly used construction materials and are listed by the manufacturer or facility. The materials are qualified and listed by Publication 408 construction specification. An example is Section 218 for the foam glass aggregate. Now for some examples. This is the cured in place pipe repair material, which was included in PennDOT's research project, which resulted in a draft trenchless pipe repair specification. This line of products minimizes the need to dig up the roadway and cause extended motorist delays. Now that this line of products can address several environmental concerns, it has become the desired product in this group. The next example is the InQuick bridge system, which is an innovative semi-modular method used to build reinforced concrete bridges. By combining prefabricated steel formwork and rebars, it allows crews to assemble and pour bridges in days rather than months, significantly reducing construction time and labor costs. The next example is the foam glass aggregate. A handful of cleaned recycled glass is in the top left photo. It uses all colors and sizes and is then milled into powder and mixed with a foaming agent. The bottom left photo shows you an unused pile of the aggregate on the left of the dollar bill, and some of the used aggregate on the right side of the dollar bill. The top middle and top right photos were taken on the I-95 emergency bridge project a few years ago when a tanker fire destroyed the bridge. The lightweight aggregate was used during the temporary bridge phase to help reopen the interstate quickly. The AASHTO Pavement Marking Test Deck is a nationally recognized effort to evaluate the performance of pavement marking materials. The dry time, durability, and retroreflectivity are three of the most important attributes of these materials. In addition to the standard yellow and white markings, PennDOT is also interested in the durability of other colors like red and green. In urban environments, the green markings are designated bike lanes and the red markings are designating bus lanes. New products can also come from homegrown ideas like this traffic control device used in flagging operations in our work zones. The use of this device was granted experimental approval from the Federal Highway Administration and deployed through the Bureau of Operations pilot effort, which used PennDOT's maintenance crews. The development and deployment of this device was recognized in 2025 for a PennDOT Innovation Award. This just shows you that new ideas don't have to come from nationally recognized materials and products. Several innovative homegrown ideas are developed by PennDOT employees every year. As new technology becomes available, we are always interested in researching and evaluating new and innovative products, especially when they are best practices in other states or materials evaluated by nationally recognized research or testing facilities. The three groups listed on the top of the slide are nationally known for extensive research and product evaluations. Additionally, our trade associations play a key role in identifying new materials and technologies and sharing them with PennDOT. In summary, our section has been doing a small but important part to bring new products and materials into Pennsylvania. By working with our lab counterparts, we ensure that these new products and materials meet the quality and performance standards that have been developed. That ends the overview of my section, and now for the next presentation, I would like to introduce Bev Miller, the Chief Engineer of our Geotechnical section.
Thank you, Matt. I am Beverly Miller, Chief Geotechnical Engineer, here to talk to you about the Bureau of Construction and Materials Geotechnical Section. The Central Office Geotechnical Section has personnel in the Materials and Testing Lab in Harrisburg, as well as regional geotechnical engineers in Districts 2, 6, and 11. We have 5 engineers and 2 instrumentation specialists. The engineers in this geotechnical section are assigned to PennDOT engineering districts close to the region that they report to. For example, Dennis Neff is located in the District 2 Clearfield office and is Regional Geotechnical Engineer for Districts 1, 2, and 3. One of the geotechnical section's functions is to assist the districts with various geotechnical aspects of projects. This includes planned and emergency projects. Assistance is provided for landslides or rock falls, structure foundations, including shallow and deep foundations, and unusual foundations such as helical piles, for retaining walls such as mechanically stabilized earth walls, pictured at the right, soldier pile walls, soil nail walls, etc. The geotechnical section also provides district assistance for various types of ground improvement, such as compaction grouting, column-supported embankments. You can see the schematic at the top right, and for sinkholes or subsidence, like in the photo depicting a dip in the roadway from mining at right, and geosynthetically reinforced slopes, pictured lower right. The geotechnical section's 2 instrumentation specialists are available to assist in the field for things like flying our drone to view rock slides, using the camera crawler to inspect pipes, using the down-the-hole camera with its scanning capability to understand the extent of a sinkhole or void, performing testing using the cone penetrometer, and using our ground-penetrating radar unit to locate shallow pipes or voids. They can also read inclinometers or water level loggers to understand the progression of slides or the fluctuation of groundwater levels. This slide shows a photo of our drones, as well as a photo taken with the drone showing a rock slide. It is much safer and provides a better overall view than traversing the slope. And here is the drone providing a literal bird's eye view. Here we have a few photos of the camera crawler at left, the camera crawler and inspection van at the right, and the camera crawler during an inspection of a corrugated metal pipe in the center. Here are a few photos of the down-the-hole camera. You can see the camera in a boring in the photo on the left, and the photo or video provided by the camera on the right. Here are a few photos of a void or a cavity using the down-the-hole camera. As mentioned, the down-the-hole camera has the capability to scan the cavity and estimate its volume. The geotechnical section is responsible for maintaining and updating Publication 293, the Geotechnical Engineering Manual, which provides guidance for all things geotechnical, work processes, lab testing, geotechnical parameter selection, acid-bearing rock, slope stability, settlement, and more. It's our geotechnical gem. We are also responsible for maintaining and updating Publication 222, the Geotechnical Investigation Manual. This is the down-to-earth publication for all things subsurface exploration, including information for becoming a certified drilling inspector, drilling inspection requirements, standardized soil and rock descriptions, subsurface boring, sampling and testing, contract administration, and driller contractor prequalification. The geotechnical section is responsible for reviewing and performing acceptance testing on various geotechnical software. A list of our currently approved geotechnical software and their function is listed on the slide below and is also available on PennDOT's website. We are also working toward a geotechnical database management system, which will contain geotechnical information from software as well as historic information from reports, scanned forms, and collected through other software. This slide shows a few of the standardized geotechnical reports that you may have seen when reviewing project documents. The geotechnical section is responsible for a handful of RC standards, such as those for geosynthetically reinforced slopes or the geosynthetic reinforced bridge approach, designed to reduce the bump at the end of the bridge. We also update or develop new standards and specifications, such as those for geosynthetics, subgrade undercuts, and compaction requirements in Pub 408. The geotechnical section has many other functions. We offer annual compaction training, periodic software training, conduct the district geotechnical engineers meeting, and facilitate attendance at the ASCE Geotechnical Conference. We also work with the training division for NHI geotechnical trainings. The geotechnical section is active in various types of research, including through NCHRP, Pooled Fund, PIT iRise, and PennDOT's IDEAS program. In the geotechnical section, we like to keep a sense of humor. Our icon is Sisyphus, the individual that had to push a rock uphill each day, though we do get the rock over the hill on occasion. Our section motto is, we do it all, because everything is built from the ground up. Thank you very much for your attention. The next speaker is Sherry Hartman, Chief of the Engineering Automation and Services Division.
Thanks, Bev. We are the Engineering Automation and Services Division within the Bureau of Construction and Materials. Our division has 7 service areas: construction services, laboratory systems management, Keystone Systems Management, photogrammetry and survey section, UAS, CAD, and the Project Delivery Collaboration Center. Construction Support Services helps manage construction field office equipment and supplies, prepare CTs for Pub 408 revisions, provides statewide MC app and PPCC support, coordinates and leads the in-person project delivery workshop with the hybrid inspector in charge breakout session. It also coordinates the APC spring and fall seminars. Laboratory Systems Management. Maintenance and support services include updates, releases, and maintains Electronic Construction and Materials Management System, known as ECAMS, Electronic Quality Management System, EQMS, and the Quality Assurance Reporting System, QARS. Keystone Systems Management support services include business partner registration. Companies and municipalities can request to become a business partner with the Commonwealth, which allows them to work as a construction contractor, consultant, or government agency within the Engineering and Construction Management System, known as ECMS, to conduct business with PennDOT. Private sector organizations can also register for additional DBAs or doing business as types such as bridge, e-permitting, traffic signal asset management system, highway beautification management system, small business applicant, bonding agency, etc. IT portfolio, assisting and leading IT portfolio projects through development, implementation, and maintenance. Overseeing IT procurement process, including initiation, request of software, IT vendor risk assessments, software license agreements, waiver submissions, request for quotes, submission for procurement, and yearly renewal and maintenance. Photogrammetry and Surveys provides district survey unit support, procures and refreshes field equipment for the survey units to make sure we are up to date and working properly. Keep software warranties up to date so there are no version issues or compatibility across systems. Update and provide trainings for current workflows as well as new or modified workflows. Photogrammetry provides base mapping from remote sensing in a specified cap, layout quality controls, measure and report accuracies for quality assurances, ensure that man-hour estimates are within 10% of department estimates based on project size and scope. Research and review new technologies to determine if it can make our processes more efficient while maintaining our standards. We recently added standard LiDAR, which is approximately 30 points per square meter, to our open-end flight contract, which allows us to capture imagery and LiDAR from fixed-wing or unmanned aerial systems prior to the project being funded, and it is accurate to about 1 inch vertically. We've also tested newly developed HD LiDAR from fixed-wing aircraft through one of our consultants to allow less time spent on busy corridors and have achieved vertical accuracies near ½ inch with proper ground control measures taken. We have newly procured mobile mapping system, developed workflows, allows for fast and very accurate mapping on hard surfaces along corridors, developed workflows for data fusion between mobile and terrestrial LiDAR for high traffic areas, We've demoed and tested UAV LiDAR systems and will be implementing this technology into our projects and workflows to round out our survey-grade LiDAR capabilities. Our drone program rolled out in 2021. We certify and help train our Part 107 pilots to fly for the department. We manage and maintain the department's fleet of UAVs. We can fly construction sites prior to the beginning of construction for current conditions. Help districts procure and implement construction analytic software platforms for routine flights throughout the life of a project. Capture post-construction conditions. They're used in structure inspections to limit lane closures and safety concerns. Helps getting imagery on environmental measures in hard-to-reach areas for asset assessment and maintenance planning. Most recently are being employed for graffiti removal. We provide support for 2 CAD platforms, an Autodesk, multiple training sessions for roadway, bridge, and survey, test and publish multiple iterations for the PennDOT State Kit, successfully led 4 Autodesk pilot projects. In Bentley, OpenRoads Designer developed a new course, ORD Fundamentals, and facilitate 2 classes, complete validation sessions for new iterations of ORD. Also provide customer support to the districts through remedy tickets, resolving 250 plus support tickets in dual platforms. And lastly, to tie all our services together into one platform is PDCC, Project Delivery Collaboration Center. It is the digital backbone that is platform inclusive. What exactly is PDCC? It is the design hub and acts as the interface between the different PennDOT systems needed through the life of a project. User role authorizations are created for workflows, dashboards, and the separation of duties. It automates a significant portion of the current design business processes and truly enables design teams to perform their daily tasks as a collaborative team. Collaboration Center interacts with other department systems such as eCAMS, eCMS, MPMS, and e-ticketing platforms. It can contain utility datasets, right-of-way plans, design drawings, models, as-built, and etc. And that ties together all of our engineering automation services here in the division. I'm Michael Barrett, Photogrammetry and Survey Section Manager in the Bureau of Construction Materials. Next up is the Construction Quality Assurance Division. Thank you.
Thank you, Mike. And as mentioned, I am Mike Hoffecker, the Construction Quality Assurance Division Chief. Here at Construction QA, our main responsibilities include administering the Materials Acceptance Program, creating and revising department specifications and policies, and providing and administering training. So what exactly is the Materials Acceptance Program? In short, the intent of the program is to ensure that construction materials, practices, and inspection procedures are consistent with contract requirements and department policies. Our Materials Acceptance Program consists of 2 parts, an Independent Assurance IA program and a Quality Assurance QA program. The Independent Assurance Program is required by the Federal Highway Administration, and its intent is to provide an unbiased and independent evaluation of our certified technicians, testing equipment, and the sampling and testing procedures. This is accomplished by Construction QA performing independent assurance reviews on aggregate quarries, asphalt plants, and projects containing concrete construction operations. The IA procedure is slightly different between aggregate, asphalt, and concrete. However, all procedures follow a similar process. During the day of the operation, material testing is completed by the contractor or producer's technician, and a comparison test is completed by a certified PennDOT representative from the same sample at the site. Material from the same sample is then sent to the PennDOT Materials Testing Lab, which is also tested and compared to the contractor or producer's test result. The test results from the certified PennDOT representative and PennDOT Materials Testing Lab are compared to the contractor or producer technician's test results. If the comparisons are within the established IA tolerances, we can be reasonably assured that the contractor's technician performed the sampling and testing correctly and their equipment is in satisfactory condition. However, if the comparisons are outside the established IA tolerances, a construction QA representative will perform an investigation as to why the failure occurred. The district will also be made aware of the failure so that they may conduct their own investigation. During an investigation, the equipment, sampling procedures, and testing procedures are reviewed. When the source of the failure is pinpointed, corrective action will be taken. A construction QA representative will then perform a follow-up review to ensure all of the deficiencies have been corrected. And as stated, the second part of our materials acceptance program is our quality assurance program. While the IA program focuses specifically on aggregate quarries, asphalt plants, and concrete material operations, the QA program is more diverse and flexible. The QA program focuses more on reviewing a wide variety of different construction field operations to ensure the construction procedures and material being incorporated into the project meet PennDOT policies and specifications. While not a comprehensive list, some of the operations that a construction QA representative may review include asphalt or concrete paving, pipe placements, subbase or structure backfill operations, substructure and bridge deck placements, and guide rail installations. If a QA representative witnesses construction procedures or other activities being completed on the project that do not meet PennDOT specifications, the finding is documented and discussed with the project inspection staff. Along with documenting the finding, a recommendation will be given to the inspection staff to resolve the issue and ensure that the specifications are met moving forward. The intent of our QA reviews is to educate and improve our construction and inspection operations to maintain PennDOT's desired level of quality work. While performing our IA and QA reviews is an important focus in construction QA, we will also revise our specifications to ensure we are keeping them up to date with emerging innovations. Research and technology continually improve construction and material best practices. As a result, it is necessary to revise and update these specs. We consider comments and recommendations from our internal subject matter experts as well as our industry partners when making our revisions. This allows all parties involved with building and maintaining our roadway infrastructure to have input. The last topic I wanted to touch on is construction QA's involvement with training. Our division is responsible for developing and delivering the NECEPT Concrete Field Technician course, which is required to be completed by all concrete technicians and inspectors that will be involved with concrete field testing. Hundreds of individuals attend these training courses every year. The Construction QA division has decades of experience in construction and materials. Because of this, we are often asked to present at district winter schools and other annual trainings, such as the Inspector Training Workshop and Project Delivery Workshop. And of course, we are always more than willing to provide on-the-job training out in the field when we are performing our reviews. As you can see, the Construction Quality Assurance Division plays a critical role in ensuring the materials incorporated and the construction practices used on our projects meet PennDOT's high standards to create and maintain long-lasting infrastructure. I appreciate your attention to listening to not only Construction QA's presentation, but for listening to all of the other division and section presentations within the Bureau of Construction and Materials. Now that all of the presentations have been completed, we will shortly open up the discussion for some Q&A. Thank you very much.
Many thanks to all of our presenters for sharing their expertise and insights with us today. Now we would like to hear from you, our audience members. If you have a question for any of today's presenters, please submit it using the chat feature. Anya Walker from PennDOT's Bureau of Strategic Business Operations will facilitate today's Q&A session. While we're waiting for the questions to come in, please take a moment to review the links in the chat box. If you would like to receive 1 professional development hour credit for attending today's webinar, please click the PDH link and complete the brief survey. Now, let's turn to the audience for questions. Anya?
Yes, so first of all, thanks to Sherry for answering our first question that is in our chat here. It had to do with the ability to obtain e-certifications that are completed in eCAMS. And we did get another question in here. Anthony is asking, is it possible to update the eCAMS bulletin search to include attachments labeled as product specification from their application? Some district staff have said this would be helpful when verifying products on construction projects. I'm not sure who would be the right person to answer. If this is also a question for Sherry, I can also add her as a presenter to be able to unmute.
Sherry would probably be the best to answer that.
I'm sorry, did you say, do you want me to see if Sherry can join?
Yes.
Okay, let me see if I can add her. Give me 1 second here. Sherry, I'm putting you on the spot.
It looks like Sherry did answer the question. She said this should be
she did
something.
already?
Yeah, she just responded. It said this would be something the eCAMS team would need to discuss with the Bulletin 15 manager.
Okay, wonderful. Thank you, Sherry. I did add you.
I see that you did. So just to clarify, we'd have to discuss feasibility and ensure that that document would be valid moving forward, that there wouldn't be changes. And if there were, what we would need to do to ensure that we always have the most accurate data there. So it's a conversation that would need to happen.
Great. Thank you, Sherry. I appreciate that. See your whether the PowerPoint will be available after today's session. Yes, we will send out a follow-up email with the PowerPoint, also the recording to the webinar, so you can share that with employees that weren't able to participate today, and we'll also link it on the website. Okay. I don't see any other questions here at this time. Since we are at 10:59, I think what we're going to do is I'm just going to kick it over back to Alicia to close us out, and I'll post the links again here in the chat too for everybody.
All right, thank you, Anya. And thank you. We had some great questions from our panelists today. If your question was not answered during today's session, you're welcome to submit it to dotinnovations@pa.gov. We will work with our presenters to provide a response following the webinar. Again, I'd like to extend my sincere thanks to all of our presenters for their time and contributions today, and to each of you for joining us and participating in today's webinar. Again, we have 2 links in the chat box. The first is a quick feedback survey that we'd like for you to complete. The second link, again, is to request 1 professional development hour for participating in today's webinar. And obviously, your feedback is very valuable to us and will help us plan future events. I would like to remind everyone to look out for the invitation for the next Innovation in Motion webinar, Collaborative Insights, How Research Supports and Strengthens PennDOT's Mission. And that'll be held on Tuesday, August 11th. If you have any innovative ideas to share for future webinars, again, we would love to hear from you, and you can send those at the dotinnovations@pa.gov. Thanks again for joining us today, and we look forward to your participation in future webinars.